Hello friends, welcome to my scholars. Learning made simple. This is Samir. In this video, we shall learn about the science class 7th, motion and time, chapter 13, all the exercises which are in the back of chapter 13 NCERT. So first question is this: classify the following as motion along a straight line, circular or oscillatory motion. So motion of your hand while running. While we run, our hand move like this, which is an oscillatory motion. So it is oscillatory motion. Motion of horse pulling a cart on a straight road. Since the horse is going on a straight road, therefore its motion will be a straight line motion. So answer is straight line motion. Motion of a child in a merry-go-round. So merry-go-round moves circular like this. So that is a circular motion. Motion of a child on a seesaw. Do you know seesaw? Seesaw is like this. Seesaw moves like this. Down, up, down, up, down, up, down, up. So this is an oscillatory motion. Motion of a train on a straight line. So it is very clear from the question. It is an straight line. It is a straight line motion. Which of the following are not correct? Means that which of the following are incorrect? The basic unit of time is second. So it is 2. It is correct. The basic unit of time is second. Second part of question 2. Every object moves with a constant speed. So it is not correct. Since all the objects cannot move with a constant speed. Some objects move with more speed, sometimes object moves with less speed. Distance between two cities are measured in kilometers. It is correct. Since we measure the distance between two cities in kilometers. Next, the speed of a train is expressed in meter per hour. It is not correct. Since we measure the speed of train in kilometer per hour. Question number 3. A simple pendulum takes 32 seconds to complete 20 oscillations. What is the time period of the pendulum? Oscillation means pendulum move like this. So this is known as oscillation. So the time taken for 20 oscillation is 32 seconds. And we want to know the time period of the pendulum. So we shall divide 32 by 20. Time taken for one oscillation is equal to 32 upon 20. Means the time taken for all the number of oscillation upon number of oscillation. 32 upon 20. This will give us 1.6 second. So the time period of such pendulum is 1.6 second. Question number 4. The distance between two stations is 240 km. A train takes 4 hours to cover this distance. Calculate the speed of the train. As we know that distance is given here 240 km. Time taken is 4 hours. We have a formula, speed is equal to distance upon time. So we can calculate the speed of the train by using this formula. Distance is 240, time is 4 hours. 240 is divided by 4. This way we shall get 60 km per hour. So the speed of the train is 60 km per hour. The odometer of a car reads 57321.0 km when the clock shows the time 8:30 am. What is the distance moved by a car if at 8:50 am the odometer reading has changed to 5733.0 km? Calculate the speed of the car in km per minute during this time. Express the speed in km per hour also. For the solution, this odometer reading at 8:30 am is 57321.0 km and reading at 8:50 am is 57336 km. So the distance travelled is the reading at 8:50 am minus the reading at 8:30 am, which is 57336.0 minus 57321.0. That is 15 km. We know that speed, again we shall apply the same formula, speed is equal to distance upon time. So the speed of the car is 15 km is the distance travelled by the car and time taken is 20 minutes. Since the time taken here is 8:50 to 8:30 am, which is 20 minutes, or the speed is equal to 15 upon 20 into 1 upon 60 in minutes, turning hours into minutes. So that is speed is equal to 15 into 60. This 60 will go in numerator and upon 20. 20 3s are 60. 15 3s are 45. So speed is now 45 km per hour. Salma takes 50, question number 6. Salma takes 50 minutes from her house to reach her school on a bicycle. If the bicycle has a speed of 2 km per second, calculate the distance between her house and the school. For this, we have solution. Salma's bicycle speed is 2 meters per second. Time taken by Salma to reach school 15 minutes. We shall turn this 15 minutes into seconds, that is 15 into 60 seconds. We know that distance is equal to speed into time. Distance is equal to speed into time, or distance is equal to speed is 2 km per hour, time taken is 15 minutes, so turning it into seconds, so that is 60. 15 with multiplied with 60, 1800 meter. Now we want to measure distance in kilometer. So 1800 upon 1000, as 1 meter contain 1 upon 1000 kilometer. Since 1 meter is equal to 1000 meter is equal to 1 kilometer, or 1 meter is equal to 1 upon 1000 kilometer. So that is 1.8 kilometer. Distance is 1.8 kilometer. Question number 7. Show the slope of the distance time graph for the motion in the following case. We have to draw distance time graph. A car moving with a constant speed. When any object moves with a constant speed, its graph remains like this. Means that speed is constant. The time and distance are equal. Time and distance are in the same ratio. So this way the graph will pass from the origin and will be a straight line as it is. A car parked on a side road. For this, the graph will be represented by this red line. Since the car is parked on the side of road, distance time graph for a parked car is this. Distance on y-axis and time is taken on x-axis. Now the car is parked, so there is no any change in the distance of the car with respect to the time. So this way it will be on x-axis. It will coincide with x-axis, we can say. Question number 8 now. Which of the following relations is correct? Speed is equal to distance into time. Speed is equal to distance upon time. Speed is equal to time upon distance, and speed is equal to 1 upon distance into time. Solution is this option second is correct, since speed is equal to distance upon time. Now question number 9. The basic unit of time is kilometer per minute, meter per minute, kilometer per hour, meter per second. Option 4 is correct, since the basic unit of time is basic unit of speed is meter per second. Since the basic unit of speed is meter per second, a car moves with a speed of 40 km per hour for 15 minutes and then with a speed of 60 km per hour for the next 15 minutes. The total distance covered by the car is solution. Distance travelled by the car in first is 15 minutes is equal to speed into time. Distance is equal to speed into time. Speed is 40 km per hour. Time taken is 15 minutes. So we shall turn this into hours. 15 upon 60 hours. 15 minutes is equal to 15 upon 60 hours. And reduce this. And after reduction we shall get 10 kilometers. So distance travelled by the car in last 15 minutes now. This was the distance travelled by the car in first 15 minutes. Now the last 15 minutes. 60 km per hour. Speed was 60 km per hour into time is taken 15 minutes. So 15 upon 60 in hours we are turning. So 60 is cancelled with 60. We are getting 15 km. Total distance travelled by the car is equal to 10 km plus 15 km. Means that 25 km. So the option second is correct. Suppose the question number 11. Suppose the two photographs shown in figure 13.1. You can see in your book the figure 13.1 and figure 13.2 had been taken at an instant or at an interval of 10 seconds. If the distance of 100 meter is shown by 1 centimeter in those photographs, calculate the speed of the first car. So As we observe the photograph 13.1 and 13.2, we find that we have a speed is equal to distance upon time. And in figure 13.1 and 13.2, we observe that the distance travelled by the blue car is more. The blue car is fastest. Now the position of the blue car in figure 1 is 2.7 centimeter from top. And the position of the blue car in figure 13.2 is 5.2 centimeter from the top. So the distance on figure is equal to 5.2 minus 2.7. 2.5 centimeter is the distance travelled by the car in 10 seconds. So actual distance is 2.5 into 100 meter. Since 1 centimeter is equal to 100 meters, so 2.5 into 100, 250 meter is the distance on road. Since 1 centimeter is equal to 100 meter on the road, on figure, it is given a scale. So speed is equal to distance upon time. Speed is equal to 250 meter as we have seen in figure 250 meter, and time taken is 10 seconds. So 250 is divided by 10. We will get 25 meter per second. Now we need to convert this into kilometer per hour as it is given in question. So 25 into 60 into 60. Since we are turning this out seconds into hours, so in denominator we shall take 1000 upon 60 into 60, and that 60 into 60 will come in numerator. So 25 into 60 into 60, reducing 0 with this 0, 0 with this 0. 25 fours are 100, we can reduce, and after reduction we get 90 km per hour. Now question number 12.12, figure 13.15 shows the distance time graph for the motion of two vehicles A and B. Which one of them is moving fastest or faster? Which one of them is moving faster? So there are two vehicles, graph of two vehicles are given, A and B. Distance, this is distance on y-axis and this is time on x-axis. It is clear that time on x-axis taken by car B or vehicle B is more than the time taken by vehicle A, and distance travelled by the vehicle A is more, which is mentioned with red color, and the vehicle B is mentioned with blue color. So distance is less, time is more. So distance time graph for two cars, solution, a car A is moving faster or the vehicle A is moving faster. Since the distance travelled by vehicle A or car A is more in less time, time is less here, time is less, and the distance travelled is more. And the distance travelled by the car B is less in more time. This less distance in more time. Now question 13. Which of the following distance time graph shows a truck moving with a speed which is not constant? This is distance and this is time. Speed is constant. This is distance and this is time. This speed. This is distance and this is time. The speed is not constant in this graph. So the solution is this. Option third is correct. Since the curve of the graph, this curve shows that the truck is moving with a speed which is not constant. This speed is not constant. As you see, the speed is increasing. not constant. Here also the speed is constant, and in this case the object is stationary since the distance is not traveled by the object with time. So this way object is constant in this case. Rest of the question in next video. Please like and subscribe our video. Thank you for watching, my scholars.